All right, so this is our final notes for this chapter 4.3. Remember, we started out with working machines. Um, for work to be done, an object must move. A force is applied, and the object must move. And we talked about this guy pushing the lawnmower. He's applying a force. You can see the arrow right here in this direction. And the lawnmower moves in that direction. We learned how to calculate for work. And we also know that work is only done as long as, in this picture especially, when the ball is in her hand. As soon as that ball leaves her hand, work is done. She's done doing work. Different types of simple machines: lever, wheel and axle, pulley, inclined plane, a wedge, and a screw. A compound machine is a combination of simple machines. We learned how to solve for efficiency, calculate efficiency. How are machines useful? They either increase the speed, change direction of force, or increase the force. We learned how to calculate mechanical advantage. Then here was the homework help. Describing energy. Work transfers energy. We learned the different ways that energy is transferred or can be transferred. All energy comes from the sun. There's different forms of energy, but all of it comes from the sun. We learned about kinetic energy, how to calculate it, gravitational potential energy, and how to calculate that. And that brings us to conservation of energy. All right. The law of conservation of energy states that energy cannot be created or destroyed. Energy can only be converted from one form to another and is transferred from one place to another. Now, conservation of energy. Energy cannot be created or destroyed. And when you watch my notes, you'll understand this. Now, when I used to ghost hunt all the time, I was looking for energy, remnants of energy left by people that had deceased or animals that have deceased. Looking for that energy. Is there any, if energy cannot be created or destroyed? Now, a lot of people, including myself, think you go right to heaven or hell or whatever, but whatever your belief is. But that energy goes someplace. It cannot be destroyed. It's still here. So that's what a ghost hunter is looking for. We're looking for that leftover energy. All right. Conserving resources, that's like, hey, turn the light off, that kind of thing. But we don't talk about it that way in science. All right. We talk about energy transformations, going from one place to another. Now, here is it's talking about mechanical energy. And mechanical energy is the total energy, kinetic and potential energy of a system. So right here, let's look at one of these apples. I'm going to try to draw an apple here. Probably be pretty bad, but there's my apple, okay? And let's just say this apple has 100 joules of energy. Right now, its kinetic energy is 0 joules. And its gravitational potential energy would be 100 joules. Mechanical energy, 0 plus 100 is 100 joules. So as this apple starts to fall towards the ground, when that apple breaks off of here and starts falling towards the ground, what happens is it's losing height. And remember, gravitational potential energy is height times mass times gravity. So it's still the mechanical energy, and I should put that up here, mechanical energy equals, mechanical energy is always going to be 100. I cannot create or destroy energy. But what happens is the kinetic energy, it's starting to move. So the kinetic energy is going up. Let's say it's 25 joules. Then because of the apple losing height, it's starting to lose Gravitational potential energy. Notice 75 plus 25, 100. When it's halfway, when that apple gets halfway, when it's halfway, mechanical energy is still 100. That's not going to change. But my kinetic energy is 50. It's halfway. My GPE is 50. 50 plus 50 is 100. As it approaches the ground, as that apple approaches and hits the ground, my kinetic energy, just before it hits the ground, my mechanical energy again, 100 joules. I can't create or destroy. When that apple hits the ground, it loses its kinetic energy. It also has no gravitational potential energy. When that apple's on the ground, here it is. When it's on that ground, as it hits the ground, though, some of the energy is transferred into the ground. Not a lot, but enough. Most of it, though, is going to be transferred into sound energy. You'll hear the apple hit the ground, and that's where that energy comes from. As that apple comes down and boom, hits the ground, you're going to hear it hit, and the kinetic energy is going to be changed into sound energy. All right, again, here we go. Before this girl hits the ball, it's a high kinetic energy once they hit it, a low potential energy. But as it rises, it slows down as it gets up here. Now it has a low kinetic energy and a high gravitational potential energy. Remember this height, gravitational potential energy, height times gravity times mass. So the higher it is, the more potential energy. As it starts to drop, H goes down, kinetic energy goes up, and gravitational potential energy goes down again. Same thing going on in a swing right here. Right here. Well, let me change my color so we can see it a little better. Right here. High gravitational potential energy. High gravitational potential energy is high. See it? Right here. There it is. Kinetic energy is lower. As you're starting to come down, kinetic energy goes up, gravitational potential energy goes down. When I'm at the lowest spot, the lowest gravitational potential energy, the highest kinetic energy. As we start to climb, kinetic energy starts going down, potential energy goes up. All right. That's the way energy transformations take place. There's other types of transformations, though, also. From the food you eat, the energy and the chemical bonds in the food you eat gives you the energy to run, to play. There's also the effect of friction. As this person is swinging, we're going to lose energy to air resistance. It transfers to the air, okay? And it turns into friction here, air friction. As you go, that's why you have to pump your legs. If you quit pumping your legs, you'll eventually come to a stop because of friction. All right. So you have to keep pumping those legs to keep that swing going. Transformation of electrical energy to heat energy, to radiant energy or light energy. If you ate toast this morning or a Pop-Tart put in a toaster, electrical energy to heat energy that cooks the food for you. Transferring chemical potential energy. Chemical potential energy in gasoline makes the car or the bus or your motorcycles, anything like that. It transfers it to motion, the chemical potential energy to motion. Here's power. Power. For some reason, my pin's not. Oh, it's because I'm in white. We got to change color. There. So power power. Power is how much energy is used divided by time it takes to use it. Okay, and power is measured in watts. Scroll down here a little bit. If a runner's power is 400 watts, P equals 400. As she runs, how much chemical energy does she convert into other forms in 10 minutes? All right. Well, we would put our time here and our energy here. Time is 10 minutes. First thing we would have to do is switch 10 minutes to seconds, which is 600 seconds. So energy is going to equal P times T, where P is 400 watts, times 600 seconds, and that would tell us the power, or how much energy is being used in joules, of course. All right, so that's the way we do that. The big thing that we're looking at here is the transformation of energy, going from one form of energy to another. All right. Energy conversions in your body. This is how much energy you use when you're doing different things. All right. So make sure to take a look at this and take a look at the table. Remember, though, the transfer of energy. Energy cannot be created or destroyed. It's transferred from one object to another or from one system to another. Energy is always conserved, always. All right, that's it for these notes. I hope they help. Or this lecture.